Students approach statistics in the doctoral program with a variety of thoughts and emotions. Statistically, I would say the average feeling is dread, and the most common thought is this course really necessary? So let's take a few minutes to create some historical context around statistics, and then connect that to why you have to take this course now. What is statistics? Statistics is not just math, and it's not just science. Statistics is a meta-science of collecting, organizing, analyzing, interpreting, and reporting data, where the data generally consist of empirical, real-world observations. The term statistics is often used to describe the quantitative information produced by these activities. Although the term statistics was not commonly used until the 18th century, the use of what we consider to be statistical methods dates back to at least the 5th century BCE. For example, in the history of the Peloponnesian War, Thucydides recounts how in 497 BCE, the Athenians estimated the height of the wall of Plataea by having several different soldiers count the number of bricks in the section of wall near them. The most frequent value, what we would now call the mode, was used as the typical value of the number of bricks in the wall in any given section. Multiplying this average value by the height of each brick allowed the Athenians to accurately estimate the height of the wall and build the ladder required to scale it, consequently defeating the Persians in battle. Several hundred years later, the Roman Empire collected demographic statistics about its citizens in order to understand the population, and of course, to ensure tributes could be collected from all the citizens. In 2 AD, a Chinese census under the Han Dynasty concluded there were 57.6 million people in the country, living in 12.3 million households. This was the first census for which the actual data survives. As economies and populations continued to grow over time, there was an ever-increasing need to collect, organize, analyze, interpret, and report information about land, people, commerce, and agriculture in order to make complex military, tax, and development decisions. In the 17th century, survival probabilities allowed for population growth estimates. In the 18th century, probability theory and graphical representation techniques advanced. The invention of the pie chart, which seems so elementary today, was practically revolutionary when it was used in William Playfair's statistical breviary to clearly communicate, quote, the resources of every state and kingdom in Europe, unquote. In the 19th century, the notion of the average man facilitated our understanding of complex social phenomena like crime and marriage rates. And in the 20th century, particularly with the advent of more and more sophisticated computing technology, we entered the modern statistical era as statistical tools and techniques were adopted by leaders in industry and politics. The tenets of experimental design were strengthened, and new tests in inferential statistics were developed. Overall, you can see that statistics is a powerful tool for understanding our social world. As evidence-focused doctoral scholars, you'll be constantly reading and evaluating published research studies that use statistics to try to demonstrate that certain claims about social observations are probably true. Researchers use statistical tools to support, for example, their hypotheses about leadership, organizational dynamics, organizational culture, and employee behavior. In order to use these findings to make your own evidence-based decisions in your management practice, you must be able to accept, to your own satisfaction, each researcher's line of statistical reasoning. So even though you are not mathematical statisticians, you need to be well-versed in these tools and techniques such that you can evaluate their use appropriately. This evaluation would include things like examining researchers' reported design of experiments, exploration and visualization of sample data, summary description of sample data, hypothesis testing, statistical inference, prediction making, and model building. Thus, you can see that critical statistical reasoning skills are extremely useful for making sense of the evidence and information with which you will be interacting every day. Be sure to take the time to understand the purpose and execution of each of these tests that are covered in the course. This will ensure that you are an evidence-based manager of the highest quality.